Today we will start exercise 4.2, and in this exercise we will perform the integration by the method of substitution. This method has already been discussed in the last 3 questions of the previous exercise. In this technique, we convert the given integral in terms of another variable, and then we solve that integral, and the answer of that integral is converted back into the in the form of the original variable. So let me start straight away from question number 1. Question number 1 is you have to integrate dx divided by square root a square plus x square, and we know that whenever the integrand is of the form a square plus x square, we have to put a is equal to tan theta. So we are going to make that substitution, putting x is equal to a tan theta. You could also put x is equal to a sine hyperbolic theta. So there are two ways to solve this integral. One way is to put x is equal to a tan theta, and the other way is to put x is equal to a sine hyperbolic theta. So when you will take the differential of dx, then it might be equal to a times secant square theta d theta. Similarly, when you will take the differential here, then the differential comes out to be equal to a cos hyperbolic theta d theta. The derivatives of the hyperbolic functions are studied in the school level calculus. Then your integral I becomes I equal to dx. Dx has to be replaced with a secant square theta d theta divided by square root a square plus x square, and a is equal to a square has to be written as it is plus x square. Square of x is a square tan square theta. And solve the denominator. I would get a square has to be taken as common, and it has to be taken out of the square root, and it simply becomes a. And in the denominator we have 1 plus tan square theta, that is equal to secant square theta. Secant theta gets cancelled with its square root, a gets cancelled with a, and secant theta gets cancelled with the square in the numerator, and you have just secant theta. And the derivative of the integral of the secant theta is natural log of secant theta plus tan theta, and we will prove this integral in this exercise in the question number 5. Now you had to make the back substitution. X is equal to a tan theta, therefore tan theta is equal to x divided by a. So this implies that tan theta is equal to x divided by a. Put it in here, you would get x is equal to ln secant theta is equal to square root 1 plus tan square theta, and tan theta is equal to x divided by a. So you have x square divided by a square plus tan theta, that is equal to x divided by a, plus a constant of integration, and you have I equal to natural log of simplify the terms within the square root, you would get a square plus x square divided by a square plus x divided by a plus the constant of integration, which further simplifies to square root a square plus x square plus x divided by a plus a constant of integration. So this is the answer, and this is exactly the definition of sine hyperbolic x over a, sine hyperbolic inverse x divided by a. So we can solve this also by the second method. Putting these values into your integral, you would get I equal to, instead of a, you would get a cos hyperbolic theta d theta divided by square root a square plus x square, and x is equal to a sine hyperbolic theta, that is a square, x square is equal to a square sine hyperbolic square theta. A cos hyperbolic theta d theta divided by, take a square common between the denominator terms and take it out of the square root, you would get 1 plus sine hyperbolic square theta, that is equal to cos hyperbolic square theta. A gets cancelled with a, square gets cancelled with square root, and cos theta just simply gets cancelled with cos hyperbolic theta, and you have just d theta, and this is equal to theta plus constant of integration. And what is the value of theta? You can find it from here. From here, x divided by a is equal to sine hyperbolic theta. Therefore, theta is equal to sine hyperbolic x divided by a. So theta is equal to sine hyperbolic inverse x divided by a, which means that the second method proves to be the more simpler one. So this is the answer. And next time I will not solve one question with two methods. I just have mentioned you that there are the number of ways that you can solve a given question. For example, this question could be solved with two methods, and you can justify that which method looks to be more easier. So a few of question in a few of question in future, we will use the technique of the substitution of the trigonometric functions, and in most of the questions we will usually make the substitutions of hyperbolic functions, since they are more simpler. But for this, you must be familiar with both the trigonometric identities and the hyperbolic identities. I should mention them, a few of them here. Cos hyperbolic square theta minus sine hyperbolic square theta is equal to 1. And similarly, in trigonometry, cos square theta plus sine square theta is equal to 1. Similarly, we have just learned that cos square theta could be written as 1 plus cos 2 theta divided by 2, whereas in hyperbolic function, cos hyperbolic square theta is equal to 1 plus cos hyperbolic 2 theta divided by 2. Similarly, in trigonometry, sine square theta is equal to 1 plus 1 minus cos 2 theta divided by 2, whereas in the hyperbolic functions, sine hyperbolic square theta is equal to cos 2 hyperbolic theta, sorry, cos hyperbolic 2 theta minus 1 divided by 2. And similarly, we know that sine 2 theta is equal to 2 sine theta cos theta. Similarly, in the hyperbolic functions, sine hyperbolic 2 theta is very similar. It is equal to 2 sine hyperbolic theta multiplied by cos hyperbolic theta. So these are few of the identities that we will use again and again in the future exercises. I have mentioned them in advance because I will mention them again in the future exercises, but I will not explain them again. So let we perform the second question. That is question number 2, and it is I is equal to dx divided by square root x square minus a square. Again here x square minus a square, you can put x is equal to a secant theta, or you can also put x is equal to cos hyperbolic theta. So I will put the substitutions of hyperbolic functions. So putting x is equal to a cos hyperbolic theta, so dx is equal to, the derivative of cos theta is minus sine theta in the trigonometry, while in the hyperbolic functions the derivative of cos hyperbolic theta is sine hyperbolic theta. Therefore we have a sine hyperbolic theta d theta. Put it back into your given integral, you would get I is equal to, instead of dx you have a sine hyperbolic theta d theta divided by x square, that is a square cos hyperbolic square theta minus a square. I have just mentioned you that cos hyperbolic square theta minus sine hyperbolic square theta is equal to 1. Therefore cos hyperbolic square theta minus 1 is equal to sine hyperbolic square theta. So you have I is equal to a sine hyperbolic theta d theta divided by, take a as common, you have cos hyperbolic square theta minus 1, that is equal to sine hyperbolic square theta. The square gets cancelled with the square root, a gets cancelled with a, and then sine hyperbolic theta gets cancelled with sine hyperbolic theta, and you're just left with d theta. This is equal to theta plus a constant of integration, and the value of theta can be found from here. It is x divided by a is equal to cos hyperbolic theta. So theta is equal to cos hyperbolic inverse x divided by a. Plus the constant of integration. So this was a very simple question. The next question is you have to find out the integral of tan x. Let it be I. This could be written as sin x divided by cos x. And since we can see that this comes out to be equal to cos x raised to the power x, sorry, raised to the power minus 1. Note that this is not the inverse, this is the power minus 1, that is the reciprocal. Similarly, the derivative of cos theta is minus sin theta, and we have, since we have make the use of this minus by our choice, therefore it needs to be counterbalanced, which can be balanced by writing minus out of the integral. So this is obviously balanced. Now we know that x raised to the power n dx is integral, that is 1 divided by x dx, It is natural log of x. So we can see that cos x has the power -1 and the base is cos x. The derivative of the base function must be given, and we are watching that the derivative of the base function, that is the cos x, its derivative is given just in the front. So therefore we can apply the natural log. So we have minus natural log of cos x. This was a simple point. This minus can be taken at the power of the natural log. Since you have learned this, the rules of logarithm in the very junior classes. So this can be written as 1 divided by cos x plus the constant of integration, and this is equal to natural log of 1 divided by cos theta is equal to secant theta plus the constant of integration. So this is the answer of your question. Next question is very simple and very similar. Question number 4. And in this question you have to integrate I equal to cot x dx. So this could be written as cos x divided by sin x plus sorry, no plus, and this is obviously equal to sin x raised to the power -1 multiplied by cos x dx. So by using the rule of integrals, this is equal to natural log of sin x plus a constant of integration. This is question number 4, its answer. Now the question number 5 is, you have to integrate secant x. How we can solve this question? We know that the integral of secant x is natural log of secant x plus tan x. So you can multiply and divide this thing by secant x plus tan x divided by secant x plus tan x. Why it is done? This can be understood in this step. Apply the distributive law in the numerator, you will get secant square x plus secant x tan x. The denominator has to be as itself as it is, sorry, secant x plus tan x plus dx. Now you can watch that the derivative of the denominator is given in the numerator, very similar to the previous question. For example, the derivative, that is cos x, of the denominator was given in the numerator. Therefore we have just written the natural log of the denominator. Similarly, we can watch that the derivative of tan x is secant square x. It is given secant x, the derivative of secant x is secant x plus tan x. Therefore the derivative of the denominator is given. Therefore it becomes directly equal to natural log of secant x plus tan x plus constant of integration. This is the answer. How you can also, however, you can also write it, you can write it in the systematic manner, and since I want to match the answer with your book, therefore I will further simplify it. Natural log of 1 divided by cos x plus, since secant x is the reciprocal of cos x, similarly tan x can also be written as, since it is the ratio between sin x and cos x, plus constant of integration. And in the next step, natural log of, combine the denominators and apply the LCM method. You have 1 plus sin x Now you have to make use of the half angle identity. Half angle identities. Since from trigonometry we know that sine square theta plus cos square theta is equal to 1. Similarly, sine square theta divided by 2 plus cos square theta divided by 2 is equal to 1 also. So instead of 1 we can write sine square theta divided by 2 plus cos square theta divided by 2. Also note that sine 2x is equal to 2 sin x cos x, and if in this formula you replace 2x by theta, this implies that x is equal to theta divided by 2, then you would get sine, instead of 2x you have to put theta, is equal to 2 times sine x, and since x is equal to theta by 2, so you have sine theta divided by 2 and multiplied by cos theta divided by 2. So sine theta can be written as 2 sine theta divided by 2 cos theta divided by 2, and whole is divided by, same thing has to be applied on this, cos 2 theta is equal to cos square theta minus sine square theta. This is very basic identity which is derived from cos theta plus theta and applying the fundamental law of trigonometry on it. This can also be written as cos theta by making the same substitution, putting 2 theta is equal to x, for example. So cos theta is equal to cos square theta divided by 2 minus sine square theta divided by 2. So make these substitutions here, you would get cos square theta divided by 2 minus sine square theta divided by 2, and close the absolute value here and write the constant of integration. Now look at the numerator. Numerator is a square plus b square plus 2ab, that is, it is the whole square of sine theta divided by 2 plus cos theta divided by 2. Similarly, in the in the denominator, you can apply the formula a square minus b square is equal to a minus b multiplied by a plus b, that is learned in the very junior classes. So you have cos theta divided by 2 minus sine theta divided by 2 multiplied by cos theta divided by 2 plus sine theta divided by 2. This gets cut with this plus constant of integration. Absolute value has to be written very straight. I have just made it curvy. It should not be curvy. It must be straight like this. And you're left with sine theta divided by 2 plus cos theta divided by 2 divided by cos theta divided by 2 minus sine theta divided by 2. Natural log of take cos theta by 2 as common from the numerator, then you might get sine theta divided by cos theta, that is tan theta divided by 2 and plus 1. Similarly, you have to take cos theta divided by 2 common from the numerator, and you might get 1 minus tan theta divided by 2 plus the constant of integration. Natural log of cos theta and cos theta get cancelled. Tan theta divided by 2 plus 1, since 1 is equal to tan 45 degrees, tan 45 degrees is equal to 1, and 45 degrees is equal to pi divided by 4 radians. So we have tan theta divided by 2 plus tan pi by 4 divided by 1 minus, and the last tan theta divided by 2 is 1 multiplied by tan theta by 2, therefore it can also be written as tan theta divided by 2 tan pi by 4, since tan pi by 4 is equal to 1. Now this is the fundamental law of the trigonometry, that tan x plus y is equal to tan x plus tan y divided by 1 minus tan x tan y. This is the basic formula learned in the trigonometry at the junior level. So you have natural log of, applying this formula you will get simply tan theta by 2. Sorry, there was no theta. I have just made the mistake that I have written theta here. Original variable is x, therefore you have to write x all in here. So it was x actually, plus pi divided by 4 plus the constant of integration. This is the answer given at your textbook. The last question, the question number 6, is very simple and similar. In this question you have to integrate cosecant theta d theta. This can be done very similar to the previous one, since the cosecant theta has the integral ln cos theta minus cosecant theta minus cot theta divided cosecant theta minus cot theta. Simplify the numerator, you will see that the derivative of the denominator is given in the numerator, therefore I is equal to natural log of cosecant theta minus cot theta. This will also be solved with in the similar manner. This is the answer. This is enough for you, but since I have to match it with the book answer, therefore I will simplify it further. This is equal to 1 divided by sine theta minus cos theta divided by sine theta plus constant of integration. Combine, you would get 1 minus cos theta divided by sine theta plus constant of integration. Natural log of, make the use of half angle identities, 1 minus sine square theta divided by 2 divided by 2 sine theta divided by 2 cos theta divided by 2 plus constant of integration. 1 gets cancelled with 1, and in the numerator you have sine square theta, and you have just 1 minus it, there should be a 2 sine square theta by 2, and you are left with sine theta divided by 2 divided by cos theta divided by 2, that is equal to tan theta divided by 2. This is the answer given in your text. Thanks for watching. Question number 7. In this question you have to integrate ax square plus 2bx plus c, where a, b and c are constants, raised to the power n, multiplied with ax plus b dx. You have to integrate this thing. You can solve it by putting by making the substitution. So we put ax square plus 2bx plus c, let it be equal to some other variable t, then obviously dt is equal to derivative 2ax plus 2b plus constant, derivative of constant is 0, multiply with dx. So take 2 common between the first two terms, you get 2 times ax plus b dx is equal to dt. And note that in the given integral there is ax plus b multiplied with dx. Therefore, we will separate ax plus b multiply dx. We will make it separate from here. This is simply equal to 1 divided by 2 dt. Now your integral I becomes I equal to integral of ax squared plus 2bx plus c, since it is equal to t, so t raised to the power n, multiply with ax plus b dx. This is equal to 1 divided by 2, that is taken out of the integral dt. Now this is very simple looking question, very simple looking integral, and this is equal to 1 divided by 2 t raised to the power n plus 1 divided by n plus 1, the power rule of the integrals. So this is equal to 1 divided by 2, t is equal to ax square plus bx plus c, ax square plus bx plus c whole raised to the power n plus 1 divided by n plus 1. This is simply the answer, plus constant of integration. Next question is question number 8. This is also very simple. In this question you have to integrate square root of 1 plus x divided by 1 minus x dx. So you can apply the rationalization. So rationalize the denominator in the rational expression in the square root. You would get 1 plus x whole square divided by 1 square minus x square, that is 1 minus x square, and this is simply equal to square root gets cancelled with the above term, and you have simply 1 plus x divided by square root 1 minus x square. Square root has been distributed, and this is now more simple form, which can be further simplified to by separating the denominator, 1 divided by 1 minus x square dx plus x divided by square root 1 minus x square dx. The first integral is obviously equal to sine inverse x, because the derivative of sine inverse x is 1 divided by square root 1 minus x square. Similarly, since we have to apply the power rule, we can use the substitution, or more simply, you can multiply with 2 and divide by 2 in the numerator and denominator, 1 minus x square. Square root, this can be taken above, its whole power is 1 divided by 2, so when it goes up the power just negates, that is, it becomes negative 1 minus x square raised to the power minus 1 divided by 2 multiplied by 2x. Since the derivative of the base term is 1 minus x, sorry, the derivative of 1 minus x square is minus 2x, so therefore you will multiply minus here, and you will also have to multiply minus at the outside for the balance. So you have sine inverse x minus 1 divided by 2, apply the power rule, 1 minus x square whole raised to the power minus 1 by 2 plus 1 by 2, that is 1 divided by 2, divide by 1 divided by 2 plus constant of integration, 1 by 2 gets cancelled with this one, and you're left with sine inverse x minus square root 1 minus x square plus c. This was very simple problem. The next problem is also a very simple. Question number 9. In this question, you have to integrate dx divided by a plus square root bx plus c. Sorry, dx is already written. Here we will substitute. We will put this thing, this thing equal to some other variable t. That is, we will put t is equal to square root bx plus c, square it, you would get t square is equal to bx plus c. And therefore, when you will differentiate it, you would get 2d dt is equal to b multiplied with dx. Now your integral becomes, this can also be written as 2 divided by b t dt is equal to dx. Now put back into the given integral, your integral will become I is equal to, instead of dx you would write 2 divided by b t dt and divided by a plus, in the square root, b plus bx plus c is replaced with t. Now you are left with 2 divided by b, that has to be taken out of the integral since it is constant, t dt divided by a plus t. The numerator can be made similar to the denominator by adding and subtracting a. So t plus a minus a dt divided by a plus t. Separate the denominator from the numerator terms. You would get 2 divided by b t plus a divided by a plus t, or t plus a minus a divided by a plus t dt. This thing gets cancelled with this one. Apply the distributive law, 2 divided by b integral of dt minus 2a divided by b the integral of 1 divided by a plus t dt. Simplify it, you would get 2 divided by bt minus 2a divided by b. Since we can watch that the derivative of a plus t is 1, that is given in the numerator, therefore it is equal to natural log of 1 plus t plus constant of integration 2 divided by b, the value of t is equal to square root bx plus c plus 2a divided by b natural log of a plus the value of t, that is bx plus c, plus the constant of integration. Since c is already occupied, therefore constant of integration can be named as c static. So this would be the answer of your question. Let me check it from your book. 2 divided by b has been taken as constant, so take 2 divided by b as constant, oh sorry, take it as common, then you will get, and one mistake is there, that here is minus sign. Take 2 divided by b as constant, oh sorry, common, you would get bx plus c minus a natural log of a plus square root bx plus c plus the constant of integration c static. So this is the answer given in your text. The next question is also very simple, question number 10. And in this question you have to integrate dx divided by 1 plus x square multiplied by arc tan x, that is tan inverse x. So you have to put 1 plus, sorry, tan inverse x is equal to t. Putting tan inverse x is equal to t or g, anything you want. So dt is equal to, the derivative of tan inverse x is 1 divided by 1 plus x square. And you have to write the differential here. Now your question I becomes equal to dx divided by 1 plus x square is equal to dt. And we have 1 divided by tan inverse x. Instead of tan inverse x, we are writing t. So this is very simple. This is equal to natural log of t plus constant of integration. Replace back the value of t. You would get the final result, natural log of tan inverse x plus constant of integration.